Hello world. So I'm going to do two linked videos on the use of Streamlit to make Python web apps available on the web. This first video will be looking at some basic examples just on your local machine, which has kind of got a dummy server. It can pretend to be a sort of web server, and you can sort of click on the link, and it looks like a web page and behaves like a web page. The second video will be what do you do if you want to actually host it on a cloud service, and we're going to look at DigitalOcean, which is a nice Linux-based cloud service. So let's first of all have a look at an example. So Streamlit's really nice to use. It only really does one thing, but it does it nice and simply. It enables you to put up your application that you develop in Python on the web and get user inputs and put outputs to the web. So it looks all very simple. To the user it is very simple. Behind the scenes it's obviously doing an awful lot because it's a fully contained web server, and for those who have played with web servers, no, they can be they can be quite complicated to set up. So let's start by having a look at an example. And I have one here, and this is running on a DigitalOcean server, just a cheap one. It costs, I think, $5 a month to be continuously running, so it's not a very powerful one. In here we can. This is a very simple ED queuing simulation. Let's just change, say, for example, the number of doctors, how long it takes to process a patient. So we can change that with sliders here. You can have input text boxes, whatever, and then we'll run the model. This is a Python SymPy model, and it produces the output on the web. So we have a chart here of the number of patients waiting by their priority. Also, that's queuing time by priority, number of patients waiting, and the number of doctors who are occupied at any one time. And then we've got some tabular results below here. So this chart, for those familiar with a bit of Python, this chart was made in Matplotlib, and it's very easy to just display a Matplotlib chart with Streamlit. And these results are Pandas data frames, and you just, well, you'll see. It's all very, very simple. So that's Streamlit. That's what Streamlit does. The environment's fairly basic. I don't know how customizable all the sort of HTML stuff is, but Streamlit's not really designed for that. If you want to do that, you're probably looking for another highly customizable Python web app environment like Flask or Django. But those are a lot more complicated to use than Streamlit. So we'll do some basic examples in a second. Let's just have a quick look at their website, which is streamlit.io. And here the most important thing really is the docs, sort of how to use, so that getting started, API reference. I'm going to link to a GitHub sheet or GitHub repository below, where I've kind of cobbled together all of the cheat sheets into a single image that you can easily have a look at, because cheat sheets are always handy. If only first of all to see just what are the different things you can do, and then have a play with them. Streamlit themselves are going to provide a web hosting service themselves, but I think it's important to say you don't need to use that. Streamlit is just easy to install, we'll see, with pip install Streamlit, and then we'll host a web app on DigitalOcean. But you know, it could be that they produce a nice cost-effective cloud environment themselves. I imagine that's how they're going to make money. So I guess using that service could help support them, which could be good, but we're not going to use that. Okay, so let's get going with some basic examples. And all of these will be in the GitHub repository. I mean, they all come from the tutorials on the site as well. So there's nothing particularly novel here. I think I've done a slightly different. I've done a Matplotlib chart and added some input for that. But these are all this is all basic stuff. But you can see, you know, most of what we want to do is going to be basic. It's getting some user input, having a button that says, OK, run the model now, and then providing output. Let's set up a Streamlit environment first. So we'll be good, and we will make sure that we've got a nice clean environment just for Streamlit. We'll do this in two ways. In this video we'll do it manually, typing some stuff to install what we want to install. When come on to the DigitalOcean, I'll use an environment YAML file and we'll set it up that way. But let's do this one manually. So I want to create an environment. I'm going to use Conda. You don't have to. I think Conda's really nice for setting up environments. Makes it really easy, for example, to choose the Python version you're using. So Conda create. I'm going to give it a name with -n, and I'm going to call it Streamlit 1 because I've already got a Streamlit. And I'm going to put in Python 3.8. So I think Anaconda have recently switched to 3.9 at the time I'm recording this. I prefer normally to work with a slightly older Python version. You just tend to find everything kind of has settled down and works well with it. So let's create that environment. Say yes to that. Okay, so that's created. Now we're going to activate it. Conda activate Streamlit 1, and then we'll install some stuff. Let's install Numpy. Just in case you didn't know, here you can also put version numbers, so you could say equals 1.19, for example. There are also point releases, 0.1, 0.2 of that, which you could specify, or you can let it choose the latest one. But we'll just let it pick those ones that are compatible with Python 3.8. Numpy, Pandas, Matplotlib. Let's just put those in. Now we'll say yes to that. Should do it pretty quickly because I've installed these before. It's got a sort of cached version of them that it brings rather than download it all off the web. So that's done. Now we're going to pip install SymPy for the discrete simulation, which we can have a quick look at, and Streamlit. With pip install, if you want to give it a version number, you use double equals rather than equals. I don't know why. So let's install those. And this might take slightly longer. See, it's installing a web server on your computer. So there is a fair amount that goes on with that Streamlit does for you, and it's going to hide behind the scenes. Okay. So that's our environment setup. So we set up our environment, we created our environment, we activated it, we installed some stuff with Conda, we installed some stuff with pip. Okay, let's create a basic web app straight away, and you're going to want to use sort of, well, pretty much any Python editor, whatever you're used to. What I would say is that if you're somebody who's used to using Spider, you can't run the web apps from within Spider, or at least I don't think you can. Perhaps there's a way of doing it. I'm going to use Visual Studio Code now because it's a nice environment for this type of stuff. You can also just use a plain text editor, and then I'm going to run it from Visual Studio Code, but I'll show you how to run it from just an Anaconda terminal window as well. So let's go into Visual Studio Code. And if you're not used to Visual Studio Code, don't try and take too much of this in at all. It's just a text editor, and it can run and debug Python files and lots of other languages as well. And it's good. It's nice, but you know, don't feel you have to use it. Right, I'm going to do. Oh, I'd already opened. So if I starting from scratch, I'd say open folder, and I'd open my Streamlit temp, and then I'm going to do File, New File. It may sort of ask you what type of file you want to do. If it does that, just say it's a text file, and then I'm going to save this as I'm going to call it 01. Let's just call it just basic app.py. Okay, and now Visual Studio Code, VS Code should know that I'm running, I'm writing a Python file, so it will highlight syntax, stuff like that. So what we're going to want to do first of all is we're going to import our stuff. What do we? Let's put it all in for now. Numpy import. Oh, that should be import numpy as mp. Import pandas as pd. Import matplotlib .pyplot as plt, and then we'll do import Streamlit as st. Okay, so that's all the imports we're going to need. We probably won't use NumPy. Anyway, so first thing we're going to do is let's put a title for our web app, and then we'll run the web app. So add title, and it's a Streamlit command. Title, my first web app. And let's put in hello world, because we should. Okay, that is a web app. It's not a very exciting web app. So let's run this. Now we need to run from a terminal, so I'll do it two ways. I'll do it from VS Code, and then we'll go and run it. You know, what if you were just editing a text file with a text editor and running it from a terminal? So here I'm going to open a terminal in VS Code. So this is something that you, as far as I'm aware, you can't do in Spider. Perhaps you can. We'll see. You can see now it's opened up, and it's opened up in the conda base environment, as terminals always do. I'm going to conda activate Streamlit 1. So now I've switched to my Streamlit terminal. I should make all of this a bit bigger, which I've just done. And to run this, we do Streamlit run. Make sure you save your file first. Run, and I'm in the right folder, so Anaconda's already opened, VS Code's open to having the right folder, basicapp.py. Right, that's it. Now, in an experimental server, this is just running locally, though it says you can get access on a network. I wonder how that will work. I guess we have to be on a network to find out, but you know, this isn't supposed to be cloud serving, certainly not external, and it's automatically opened up on mine. If yours doesn't, normally with these sort of things, you can, if you hover over, it says follow link with a control click, but it's already opened up, so we can see it's running on localhost first web app. Not exciting. Let's add some stuff. So we're going to close this down, and I'm going to go into the terminal, and Control C is the stop. So if you're not used to working in a terminal, something you'll probably do quite often is try and use Control C to copy, and then you actually stop any running processes that you've got and need to restart, which normally isn't a pain. I have done it when it's kind of like 8 hours into a long simulation, and then you have to restart, and that is a pain. But Control C, stopping in a terminal, goes back a long time before Control C, copy. And that on mine automatically shut down the web page as well. So we're going to add something else. Let's show a Pandas data frame, and I'm going to save just a bit of time by copying across the code here. Show a data frame, so standard Pandas nomenclature, we'll call it df, and then we're going to give it a column name and put in Bill, Ben and Bob, feeling really inspired there, and their height. And we can then show that. Now, there's a handy dandy command in Streamlit, which is Streamlit Write. And Streamlit Write does a lot of tedious stuff for you. It detects what you're trying to write and serve it up nicely. So it kind of displays stuff. So first of all, I can do Streamlit Write, and I can write some text. Here is a Pandas data frame, and then I can write the data frame, which I've called df. It's magical, this. Let's save that, and then I'm going to come down here and I'm going to rerun it, Streamlit basic app.py. And there we are. It's displayed our title, some text, and a Pandas data frame, just like that. If the data frame is big, certainly wide, I'm not sure I've done one what happens if it's very long. If it's wide, it produces a scroll bar, so on the web page people can scroll left and right to see the whole lot. Okay, so that's writing a data frame. Simple. Now let's do something a bit more complicated. Let's get in some input from a user, and then what I'll do is I'll get it to draw a graph based on that. So I'm going to want to introduce the variable power is what I want to get from the user, and I'm going to use a slider. And the slider I'm going to call power, and then I'm going to set its minimum value, min value, to be equal to 0, a max value, if I can type, max value equals 5, and I'm going to give it a starting value, sort of where it starts off on the slider, equals 2. For now, let's just do stwrite and then power is power. St.write. Okay. So we'll run that one. Dum, 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 dum. So here's our power, and as we change our slider, it's updating this. By default, when you have sliders and stuff, it kind of updates the rest. Now that can be handy if it's something quick to calculate. It can be a slight pain if actually you want to collect a whole lot of inputs and then do something like a simulation. You don't want to rerun a simulation every time somebody changes one input. You want to let them select all of them, then run. So what we're going to do is actually attach this to a button, and then we'll get it to produce a chart only when the user says, okay, I've introduced what I need to do now. So let's stop that again. Now we're going to create, I'm going to copy some of this across. I'm going to create a function for drawing a chart. So this is a very basic Python function. I'm going to first of all get it to calculate the results, and I'm going to calculate the results at x. X is going to be between 0 and 10 in steps of 0.1 using the Numpy arange to get that array of x, and then I'm going to say y equals x to the power of power. So that's going to calculate the results. Then I'm going to draw a Matplotlib chart, and the way Matplotlib now like you to do stuff, because it's slightly confusing, they got various. Their preferred way of setting up a chart is to first of all define the overall figure space, and within that you can have multiple little charts. With fig equals plot.fig, we can give it its size in inches, and then we define within that a set of axes. So this is a subplot. Figure out subplot, you actually don't need the 111. 111 means do it, this is how many wide, how many deep, and what index are you. So if I wanted to do one that was, it was going to be 4 charts in one, I would do 2 wide, say 2 deep, and this would be chart number 1. First one is 1, not 0, as with a lot of Python. Or, so I can do commas or just 2, 1, but I'm only going to do 1. I put in the 111. If you don't put 111, it's kind of assumed that it defaults to 111. So anyway, let's do it like that. Then I'm going to get it to draw a chart. So I'm going to plot on the axis x, y, going to give it a label, going to set my x limb between 0 and 10, y limb start at 0. These are the axes, label the axes, and put a legend on. Now, if you were normally in Matplotlib, you might do something like plot dot, well, you might save the figure if you want to save it to file, and you can do that on the here. I'm not quite sure where it goes. We'd have to then send it out, or you might do plot dot plot to display it on the screen, sort of say Matplotlib. Okay, I've done everything now. Put it on the screen. We want to serve it up on the web server. So this requires a Streamlit command to display it on the web server, but it's a very simple command. It is st.pyplot. What are we going to plot? We're going to plot this figure. Okay, and that's our function. That renders it to the screen. Now, that function isn't being called at the moment. So let's put in a button, and when that button is pressed, we'll call the function. And we're going to do that by saying if Streamlit dot button, and then we can give the button some text, draw chart, and when the button is pressed, we're going to call our draw chart function. Okay, let's give this a go. So I'm cobbling together a whole lot of things here that don't necessarily sort of all flow, but it's just to show you the basic bits. Okay, so we got our power, and it's updating this bit because this isn't linked into our button. And I mean, normally you wouldn't have that. That was just to kind of show what its output was. Now we click our draw chart, and there's our chart. So simple Matplotlib chart. Anything you can do in Matplotlib, you then use streamlit.pyplot, the figure, and it displays. Okay. Now we're going to do a map. The maps are really nice and really easy. We're going to first of all create a data frame that has two columns, latitude and longitude, lat, lon, and within that will be various points. Now, so this first bit just produces that data frame. And this is just putting in a whole lot of random points that are centered around a particular point. So normally you'd have a table of what are your points, what are their lat and long, and name the columns lat and long. So that creates the Pandas data frame. So to do a map, I mean, look, this is just beautiful. st map data, which is what we've created here, our Pandas data frame of some Latin longs. Save that. Let's run this. Now that's not in the button, so it will display anyway. And look what it's done. It's plotted the points, and it's automatically pulled in a base map from Mapbox, OpenStreetMap. And this base map, you can pan, you can zoom in and out, and you see it scales the map according to the zoom. Oh, with st.map, it's just magic pixie dust. It really is. Okay. One last thing in this section. Well, we'll then go on to look at the EDSIM just locally. But in these examples, these basic examples, let's upload a CSV file and get it to display it. I mean, that's all we'll get it to do. I'm just going to quickly create a CSV file. So I'm going to use LibreOffice. So we might have something like name, height. Again, I'm not being very exciting here. Jane, Sally, really am unimaginative. 1.56, 1.70, 1.65. Okay. I'm going to save that as a CSV in my where do I Streamlit temp. I'm going to call it again imaginatively data.csv. Yes, do use a CSV format. Okay. Now, and we'll get this linked to a button. So we're going to first of all define a process file and it's going to oops, sorry, ignore that for a moment. We'll have the upload, then we'll get it to print it. So upload file equals Streamlit file uploader, and then give it a name of the text to display. that's the file uploader, and it's going to upload it into File. Now, I'm going to copy across a function here for processing it, and we'll see what this does. In that it's going to once we've uploaded the file, it's just going to simply write it. Then I'm going to do PD Pandas read CSV from that file, and then write what we get from that. So we can just see a couple of steps. This is going to show what the raw upload is going to look like. This is how you convert it to a Pandas data frame. It's slightly odd that you use the Pandas read CSV method, and then write that. And then let's link it to a button. So again, if Streamlit button, give the name, then call this function process file. Rerun that. Here's our lovely map. Now this is the Streamlit file uploader. You can drag and drop. Beautiful. Just open a file manager and drop it in there, or you can browse. Let me I haven't actually used the drag and drop. Let's pop that over there. Second. So where we are Streamlit temp. Here's my data. Drag it in there, and that's uploaded. Simple as that. And then process file. So if we just print the raw file, what it's actually giving us is information around that file. So to get to the data, this is where we use the PD Pandas read CSV, and then we write that, and that's it. Okay, that's all the basic functionality of Streamlit. You can go on, have a look at the docs and the cheat sheet for some more things you can do, but it really is that simple. It's got a whole lot of simple get stuff from the user. You know, here I've used the slider, but you can see you can use buttons and whatnot, or text input or easy file input, and it's got simple methods to write stuff, map or plot Matplotlib charts. It's got its own charting as well, but since we tend to do everything in Matplotlib, or I do, I've used that, and then its function, and it's hiding all the complexity for you. Okay, so next thing we'll look at, I'll just pause a second, and we will look at what the simulation looks like. Okay, actually quickly, before we look at the simulation, let's just quickly run that from a terminal rather than VS Code. So I'm just going to go and find my file, or my directory, Streamlit, and if you're using Linux, you'll know you can open a terminal from right-click, open a terminal, and it opens in the right place. If you haven't got that, open up, if you're using Windows, for example, open up Anaconda terminal, probably is the one you want. I'm going to open up just a standard terminal here, and you would navigate. If you can't open it up from the folder, I don't know what Windows and Mac allow, I'm going to navigate to Streamlit temp. Now I'm in my base environment, so if I want to run this, I want to change to conda activate Streamlit 1. If you can't remember what your conda environment's called, so just remember conda env lists all the environments on your computer. So conda activate Streamlit 1, and then to run that I would do Streamlit run basic app. Now and there's our web app. Now this terminal has to be left open for it to carry on serving. I won't put it in this video, I'll put it in the next one. There's a handy thing called Tmux, which allows you to have terminals running, as many as you want, terminals running in the background, so you don't sort of have to keep them open on your screen at any one time. So I'm going to stop that. And let's just now have a quick look at the Python EDSIM, but importantly, I'm not trying to cover how to write SymPy simulations here. What I'll do is just show you kind of the sort of things you need to have in your SymPy simulation to get it to run with Streamlit, which is basically just to make it so that if you plot things like, if you're plotting Matplotlib charts, or if you want to show a data frame, rather than printing it or plot.show, you have it in a function and you return the object to your main Streamlit application, which you'll see is very short, and then that will display it. So let's have a look at that now. I've got it in a different folder. Let me just quickly go to there. This will all be in the GitHub linked below. Oh, sorry, where are we? Okay. Also in the GitHub will be this cheat sheet which I've just converted to an image, so you can kind of have a look if you want it in a simple file format rather than HTML. So the EDSIM, I've put all the mechanics of the simulation model in a separate Py file. So this is the EDSIM, and I'm not going to go into this because this is separate. How do you write a SymPy simulation? But the important thing is really and it's very simple. For example, here we got function which does the charting. If I was in working in a Jupyter notebook, I would end that function with plot.show to show the chart in the Jupyter notebook. Here I'm going to call this function from my Streamlit bit, and I'm going to just return that figure. Instead of showing it, I'm going to return it to Streamlit and get Streamlit to show it. Similarly, there are other bits in here where I'm going to get it to summarize text output, and it's going to send it back to Streamlit. So what I've got, when the model runs, it runs all of its simulation stuff, and then it builds the chart here, the chart output. That returns a figure to this. I get some what I've called text output. It's the Pandas data frames and some text to go with it, which I just sort of bundle all together in a list of stuff to display. And then I'm going to return that chart output and the text output to Streamlit. So let's have a look. And this, say, you can look through this example, your own time if you want to see the mechanics of the EDSIM. So Streamlit ED model is what is going to run this and serve it up. And you see it's very simple. So this is the web app. In the web app side of things, we've got our imports, we give it a title. Here I'm actually going to use another Streamlit method that's very simple, and I'm going to divide my page into 3 columns. And then I'm going to get the number of docs, and I'm going to say, well, that's going to be in column 1, and I'm going to use a slider. So here I've just replaced st with col1 because it now knows to automatically put that in column 1. I'm going to get inter-arrival time from a slider in column 2, and process time slider column thing. You can also put all your inputs in a toolbar on the left of the screen, which is really easy to do. I think it's just st.toolbar. Say button, for example, That's in the basic examples on the streamlit.io. So this is going to get, this bit gets the user inputs. Model then, the model sets up, oh, I should have said up here, I'm going to import that model, the Py file, as ed. Model then sets up that model. So the model is an object and it passes in docs into arrival. Oh, and that should be process time. See on the slider here, I haven't put min value, max value, and the starting value. It automatically assumes that order, though I think actually it's probably nicer to write min value, max value, value is clearer to the reader. I must update that, so I've saved it. In fact, let's quickly do it now. So if you've got something like this, I'm going to open in terminal. I'm going to add that new file. Which one was it? streamlit.ed.py. I'm going to commit it and say, what shall I say? Fixed bug in process time slider, for example, and then I'm going to push it up to the GitHub repository that you can download this from. There we go. Okay, that's updated on GitHub. Otherwise I would have forgotten. Sorry about that diversion. So now we're going to run the model only when you click on a button, and we're going to run the model with model.run, which is run is a method in that I wrote in the simulation, and it's expecting to return two things: chart and the text. And we're going to display the chart with st.pyplot chart, and then we're going to display the text, which is a mixture of text and Pandas data frames. They're all in a list. So I'm going to simply iterate through the list for t in text and write t. Simple as that. So let's close that down. Open in terminal. Activate Streamlit. Or I could have used Streamlit 1, basically the same. Then Streamlit run, and it is Streamlit ed model .py. There we are. So this is our first bit of user inputs, and then we're going to run the model. And gets the chart, gets this is what it's iterating through in the st.write. So that'll be a text field, that'll be a string, pandas data frame, string, pandas data frame, string. I just write it with st.write. I don't need to know the order of, all I need to know is those objects are compatible with st.write, and it will sort out the rest. And then we've got, so here, this is what happens if it's too big to fit on a web page. Presumably if I had a wider web page, no, perhaps there is a maximum width, so I sort of scroll around there. That's it for this. So that's a demo of Streamlit, and the next one we'll do is, assuming you kind of know all of that, we'll set up a DigitalOcean, what are called Droplet, sort of virtual machine in the cloud. We'll install Anaconda. We will get this from all this stuff from GitHub. We'll download it into the cloud and then run it from there. So if you're interested in that, then join me in the second video. Bye bye.